Okay, so in this video, we're going to look at projectile motion. If you take in physics 1, it doesn't really change. Okay, so we still use our equations of motion. We still have to break up initial velocity vectors and so forth. So far, all we focus on is one-dimensional motion. So the object is moving in the X or the Y. And what happens with projectile motion, the object will move in the X and the Y directions. Okay, so projectile motion is what we call two-dimensional motion. And the horizontal component of projectile motion resembles an object moving at a constant velocity. Okay, what does that mean? Our acceleration in the x direction is 0. So if you rewrite these equations, the motion equations with projectile motion, you can drop anything with an a in the horizontal direction. Now, in the vertical direction, it looks like free fall. Okay, so we cannot drop out that a. Anything. And so what does that mean? Our acceleration is going to be that negative 9.81 meters per second squared number. Or a lot of times if it's a multiple choice question, you just say negative 10. Okay, now this should say motion. Sorry, not motinos. So the combination of these two independent motions, it's very important to note that these are independent. Okay, so they don't affect each other. So what happens in the X does not affect what happens in the Y. Mathematically, if in some math classes, when you do parametric equations, a lot of the word problems are centered around projectile motion questions in physics, because that third dimension or that third factor of time, that's your parameter. And then you can just go from there. Okay, then you just add in the motion equations, and what you do is if you plot it on in a graphing calculator, you're actually plotting the X motion, the Y motion in respect to T, which is our parameter. And what happens is they produce parabolic shapes. And there's two types of projectile motion. The first one is when you launch it out horizontally. So that's this, So that's this problem right here. This is what we call a cliff problem. Okay, so know that the only thing that you have initially in the X in terms of its velocity is an X component. But what it does, because it undergoes free fall, it actually gains a Y component. Okay, and then you have ones that are launched at an angle. So when you launch them at an angle, note that you have two pieces to start. Okay, so if we rewrite the motion equations, right? So these are the important equations for projectile motion. The first thing is the velocity factors. All right, and so if I'm given initial velocity with an angle, in fact, if I'm given any initial velocity, so the angle for a cliff problem is 0 degrees. Okay, so I can, even if I plug in VOX equals VO cosine theta here, then if I plug in cosine of 0, it's 1, right? So that just tells me VOX equals VO. All right. Now, if I look at the different equations, I've got, V equals VO plus AT, and then X or Y equals X plus VOXT plus 1/2 AT squared, right? In fact, our general form doesn't include this X, it just includes the VO. And so if I were to cancel out the A in this equation, I would get X equals XO plus VOT. And then if I were to cancel out the A in equation 1 here, I would just get V equals VOX. Right? And make sure you put subscripts at this point in time, because you don't want to confuse your X and your Y's. Now in the Y direction, if I use sine in the X, guess what I'm going to use? Or if I use cosine in the X, I'm going to use sine on the Y. So VOY equals VO sine theta. And now I'm going to plug in all my, and don't forget, we got the third equation, V squared equals VO squared plus 2A delta X. That equation is not that important in the X direction, because if you did it, you would just end up with that Vx equals Vox relationship. So what I'm going to do now is I'm going to replace all my A's with negative 9.81. So Vy equals Voy minus 9.81t. And then we have Y equals Y0 plus VOYT minus 4.905 t squared. Sorry, I kind of ran off the space there. Let me rewrite that a little bit nicer. Minus 4.9 t squared. And that's a squared there. And then the last equation ends up being vy squared equals voy squared minus 19.6 delta y. Okay. And so there are our equations that we're going to move forward with. So let's look at an example problem of projectile motion. So suppose the football is punted and left the punter's foot at a height of 1 meter above the ground. What is the maximum height of the football relative to the ground? How far does the ball land from the punter if it leaves the punter's foot with a speed of 20 meters per second and an angle of 37 degrees? So what we're saying is, so here's our punter. It's going to leave his foot 1 meter off the ground, okay? And it's going to land at some distance that we're going to look for. Okay, we're given the initial velocity. So the first thing you need to do is break up that initial velocity into x and y components. So we're going to do Vox equals Vo cosine theta, Voy equals Vo sine theta. So we're going to do 20 cosine 37. Make sure your calculator is in degrees. So it's going to be 16 meters per second. And we're going to do Voy equals Vo, or sorry, this is where I'm plugging in numbers. So this is going to be 20 sine 37. So 20 sine 37, and that's going to be 12. Okay, meters per second. Now what I'm going to do is I'm going to write the equations, okay, for the x and the y. So I'm going to say x equals xo plus voxt. So I'm going to say x equals, we're going to call our initial position 0. So really it's just going to be 16.0 t. So once I figure out how far, the ball, at what time does the ball land, I can now use that equation to find how far it landed. And so now I'm going to do v equals, sorry, not v, x, or sorry, y. This will be y equals 1 meter, right? Because we're starting a meter up, plus 12t minus 4.9 t squared. Okay, so mathematically, the max height happens at the vertex. Okay, so a couple things about that max height. The Vy is 0. So I can also use the equation Vy equals Voy minus 9.8 t to figure out how long it takes to get up there, which then I can plug back into the other equation. I'm going to say 0 equals Voy minus 9.8 t, or sorry, I know Voy. I don't know why I'm neglecting that. So this is going to be 12 minus 9.8 t. Do a little bit of algebra. 9.8 t equals 12. T equals 12 divided by 9.8. It's 1.22 seconds. And so now I can take this and say 1.00 plus 12 times 1.22 minus 4.9 times 1.22 squared. Okay, and so I'm going to 1 plus 12 times 1.22 minus 4.9 times 1.22 squared. And I get it is 8.34 or 8.35 meters above the ground. Okay, so now I need to figure out how long does it take to get all the way. Well, if I set this equation here equal to 0, right, then I can do some algebra to pull that out. The thing is, because now we have an initial height, you have to probably use quadratic equation. So, right, negative b plus or minus the square root of b squared minus 4ac, all that over 2a is going to be our time. So t is equal to negative 12 plus or minus the square root of 12 squared minus 4 times negative 4.9 times 1 divided by 2 times negative 4.9. And make sure you do plug in negative signs. The other thing you do is, really what I'm going to probably do is I'm going to graph it. If I can find the right calculator. Give me one sec. I'm going to pull out my Casio, not my TI. Casio is a little bit easier to use in this regard. So I'm going to hit, so it's going to be 1 plus 12x minus 4.9 x squared. Graph it. I gotta hit zoom. Okay, so it's giving me a root. So it's going to take 2.53 seconds to get to the ground. And so now I'm going to take that 2.53, plug it over here. So it's going to be 16 times 2.53. So equals 16 times 2.53. And it's going to take, it's going to land 40.5 meters away. So this time here is our total time. Okay. Last year, you probably went from, if it was AP Physics 1, you went from ground to ground. Here, note that we start a meter up, which is the reason why in our Y equation, we have the 1 plus number. Okay. So in the next video, we're going to look at relative motion and how does that kind of play into our